Demo for plotting app that's included as part of my package RTutor. The function to launch the app is launch_plotter. It takes a list of datasets as argument. We will use the iris, empty cards, and the diamonds dataset from ggplot2 package. For diamonds, instead of looking at the entire dataset, we would extract a small subset of it using the sample function. So let's run this code. So this will launch the app, and the app would look like this. There is a readme section that provides an overview on how to use the app. We will skip it for now and directly move on to build a plot section. Now here you will see various different options that you can use to construct a plot and manipulate aesthetics related to a specific plot type. We'll start off by selecting a data set. So this drop down will show you all the data sets that you included while invoking the function. We will select the diamonds sample data set and move on to the next tab. Now in this tab you can set the x and y variable, and you can select the plot type that you're interested in. We will start off by looking at a univariate analysis. For example, if you are interested in analyzing the distribution of price of the diamond, we will select this. And by default, the app provides you a density plot. Now this is the default behavior. Depending on the variable type, the app would provide a small set of recommended plots. For example, in this case, given that price is numeric, it gives you an option to select either a density or a histogram. You could override this behavior if you want to look at the list of all available plots in this app by clicking on show all plots button. This gives you the list of all the 10 different plot types that's included in this first version of the app. Now ggplot2 has more than 35 different plot types, so this includes only a small subset of it. Let's anyway revert back to showing only the recommended plots, and let's start off with a density plot. Now this is the basic plot. We could now control specific aesthetics related to it. By default, the aesthetic controls are hidden. You could make it visible by clicking on this button. There are two different ways in which you could change the aesthetics. You could either map it to a variable, or you could manually set it. Let's try to do both. For example, if you want to map the color aesthetic to the cut of a diamond, you would now see a different density plot for each different diamond cut. We could combine this with manual settings. For example, if you want to make the line more prominent, we could change the size argument, right? So now you could see that the line is more solid and darker. You would also see that the code which generates this plot is getting displayed here. So if you are to copy this code in your R console, you will get a plot similar to the one that you see here. The other option is that you can make the plot interactive by clicking on this button. Now the interactivity is supported using the plot.ly package, and plot.ly offers a set of really nice interactive features. For example, if you it provides this tooltip, so if you hover your cursor, it will provide you the value corresponding to that point. Secondly, for example, in this case, if you are interested in comparing the distribution for only two different cut types, you could remove the others by clicking on this. Right, so now we are left with only two different distributions, and it becomes much more easier to compare between the two. By clicking on this button again, it reverts back to a regular ggplot. Finally, you could reset all the aesthetics that you have set by clicking on this reset all button, and this reverts it back to the default plot that we started off with. Now let's go back to variable and plot type. For example, now you want to look at the cut of the diamond. Now given that cut is categorical, it shows you a bar chart by default, with the length of the bar representing the count of each cut of the diamond. As before, let's modify the aesthetics. For example, in this case we will map the fill of the diamond and map it to clarity. Right, so now you get a stacked bar chart where it will show you the count of clarity for each cut of the diamond. We could combine this with let's say manual setting. For example, if you want to change the color of the border and make it black, we will select it here, and it also offers you specific controls. For example, the default behavior is stacked bar chart, but you can change the position of the bars to dodge, so it will give you this. Or if you are interested in comparing the relative proportions as against looking at absolute counts, you could select the fill option, so you will get a plot like this. Let's go back to the dodge position and let's look at one other feature of interactivity. So now we make it interactive by clicking here. Now this interactive feature helps you zoom in on specific sections of the plot. So if you're interested in looking at only the fair group, we could zoom in on this like this, and now we can look at this group in isolation. Let's switch off interactivity and let's reset all the aesthetics. Now let's look at a bivariate analysis. For example, if you want to look at the distribution of price for each cut of the diamond, we could do this. And now by default you get a box plot. You could probably change it to a violin plot. Let's move it to box. And as before, you could control the aesthetics. You could map the line type, for an example, to the cut of the diamond. Let's reset this and let's move back. So up till now we looked at all the plots that we looked at, we utilized only one layer, but there are cases where you would need more than one layer on your plot. For example, if you are interested in looking at the relationship between the diamond carat and the price of the diamond, now both are numeric, so by default it shows you a geom point, which is a scatter plot, but you could also make this into a geom smooth, which will fit a smoothing line. Now if you are interested in having both these plots, you would need two different layers. We map the same variable carat and price to both the layers. With the first layer we have geom point, and for the second layer we select a geom smooth. Now you have a smoothing line on top of a scatter plot. When we move on to this tab, you could individually control aesthetics for each layer. So let's open up the control for layer 1. Let's map the color of the point to the cut of a diamond. Let's make the points more prominent. Let's hide this and let's open up layer 2 controls. So geom smooth provides some specific plot specific controls. So for example, in this case you can switch off the confidence interval bands that you see by setting this option. And instead of the default fit, for example, you can make this into a linear fit by selecting this. Finally, you can move on to the themes tab, and this provides a set of various different themes to choose from. Some of the themes comes from the ggplot2 package, whereas quite a few comes from the gg themes package. For example, you could select options like this, or let's try a few others. Yeah, so let's finalize on this. Finally, we can add a plot title. We'll call this as price versus carat. And finally, you can, now this is rendered as an image, so you could right click and save the image. But if the plot is interactive, you don't get that option, but plot.ly provides you an option to download the plot as a PNG, right? So you can click here and download it as a PNG. Hope this helps. Thank you.